Good day everyone, I am Darwin V. Laluna, a BS Ed Mathematics second year, and today we will be discussing the normal and binomial distribution. So first, we will be discussing the discrete and continuous variables. So what is discrete random variables? Discrete random variables are classified according to the number of values which they can assume. It is a random variable that can take on an finite or countably infinite number of distinct values. Example of discrete random variables. Number 1. Number of heads obtained when tossing a coin. Number 2. The number of siblings a person has. Number 3. The number of students present in a classroom at a given time. And now, we will be discussing the continuous random variable. A random variable that take an infinitely accountable number of possible values, typically measurable quantities, and arise when we deal with quantities measured on a continuous scale, time, weight, or distance. For example, time of a person can hold his or her breath. The height or weight of a person. The body temperature. This time, we will be talking about probability distribution. Consider a dice with sides number 1 to 6. If x denotes the random variable that defines the number that shows on the top of the die, two things are true. First, the observed value of x must be 1, 2, 3, 4, 5, or 6. Second, on the given roll, the random variable x can take one of those values. The 6th outcome will both exhaustive and mutually exclusive. Hence, p sub 1 plus p sub 2 and so on is equals to 1. Properties of discrete probability distribution. The probability of each value of a discrete random variable is between 0 and 1 inclusive. The sum of all probabilities is 1, where it is the summation of px equals to 1. Example, a coin toss thrice. Let the variable x represents the number of tails that results from the experiment. This time we will be getting the number of tails. So, in the first toss, there are two possible outcomes. It is either head or tail. Then, when we do the second toss, the possible outcome will be head or it will be tail. Then here, it will be head or it will be tail again. So, when we do the third toss, it will be head or tail. Same it here, head or tail. And also here, head or tail. And also here, head or tail are the possible outcomes. So, when we toss the coin 3 times, there are 8 possible outcomes. So, the first possible outcome will be head, head, head. Then, the second possible outcome will be head, head, tail. Then, the third possible outcome will be head, tail, head. Then the fourth, head, tail, tail. Then the fifth possible outcome will be tail, head, head. Then the sixth possible outcome will be tail, head, tail. Then the seventh one will be tail, tail, head. Then the eighth possible outcome will be tail, tail, tail. So, this time we will be getting the number of tails. So, in the first outcome, there is no tail. Then the second outcome, there is one tail, and also in the third one, there is also one tail. Then in the fourth one, there is two tail, and in the fifth outcome, there is one tail, and in the sixth outcome, there is two, and also in the seventh outcome, there were also two tails, and in the eighth outcome, there are three tails. Now, what are the values of our x? So x represents the number of tails. So the value of our x is 0, 1, 2, and 3. So, what is the probability when there is no tail when you toss the coin? 3 times. So, the probability is 1 over 8. Next is, what is the probability when there is one tail when you toss the coin 3 times? So, it is 3 over 8. Then, what is the probability when there is two tails when you toss the coin 3 times? So, the probability is also 3 over 8. So, the last one is, what is the probability when there is 3 tails when you toss the coin 3 times? So, the probability is 1 over 8. And now, we will be discussing the binomial distribution. The binomial distribution is a frequency distribution of the possible number of successful outcomes in a given number of trials, each of which there is the same probability of success. Characteristics of binomial distribution. In binomial distribution, the following are true. First, an outcome on each trial of an experiment is either a success or failure, where the probability of success is the same for each trial. There can only be 2 outcomes. Second, there is fixed number of trials. Third, all the trials are independent. The probability of getting x successes in n independent trial is p of x equals to nc x p raised to x times q raised to n minus x, where p is the constant probability of a success for each trial. Example, what is the probability of getting 3 heads of 5 flips of a balanced coin? Solution, p equals to 1/2, which is the probability of getting the head. Q equals to 1 minus 1/2, which is the probability of getting a tail. And now, let's substitute. After solving the problem, the final answer is 3, 1, 2, 5. Example number 2. If the probability is 0.70 that any one registered voter randomly selected from official rolls will vote in a given election, what is the probability that 2 of 5 voters will vote in an election? The solution to solve the example number 2 is x equals to 2, n equals to 5, and p equals to 0.70. And now we will be using the formula. P of x equals to n, c x p raised to x times q raised to n minus x. And now, let's substitute. After solving the problem, the final answer is 0.132. Mean, variance, and standard deviation for a binomial probability distribution. So, the formula in getting the mean is mean equals to n times p. Then, the formula in getting the variance is sigma squared equals to n times p times 1 minus p. And the formula in getting the standard deviation is sigma equals to square root of n times p times 1 minus p. Example, The number of substandard buildings produced in a production run of n equals to 5,000 books is a binomial random variable x with the probability of p equals to 0.02 of a substandard binding. To get the mean, use this formula. Then substitute all the values and you will get 100 as your mean. Solve for variance, use this formula. Then substitute all the values and you will get 98 as your variance. To solve the standard deviation, use this formula. Substitute all the values and you will get 9.899 as your standard deviation.